I'm going to talk about remote sensing and GIS applications in hydrometeorological disaster. So this my lecture outline is like what is flood, what are the causes, what is the impact of the flood. Basically, when we say hydrological hazard, it is a mainly flood. Then principle of flood mapping using remote sensing. What are the different Earth observation system for flood management? Flood inundation mapping and monitoring, flood risk zonation, and finally flood modeling and flood early warning system. So what is a flood? Flood is an unusual high stage in the river. Normally the level at which the river overflow its bank and inundates the adjoining area. Right? For example, look at this. What you see here, that this is the river cross section, and if water is increasing because of the rainfall, and if this water flow, the overflow over the bank, and it come down here, then it become a flood. For some examples, you can see here. Now look at this. What is happening? This water is going up to here, no problem. But once it crosses this, then it become a flood. So this is the example. You can see here. Look at this. This is the place. You can see here some houses are there. This is all agriculture area. So this is flooded. Now look at this urban area. This is a lava city, and you can see this is a photograph, and you can see all flood because there was a flood in the Ganga river. Now, if you see this is another example of flood. Like this is the river is flowing, and once the river flow increases and crosses the bank, then it inundates the surrounding area. So this is a flood. Okay. So what are the causes of the flood? No doubt it is a heavy rainfall. This is the most important cause of the flood. Whenever there is a heavy rainfall, and such a heavy rainfall that river cannot, the carrying capacity of the river is not sufficient. Hence, it inundates the surrounded area and it becomes a flood. So that is the first cause of heavy rainfall. Second one is the breaching of embankment. You know that many low-lying area we are providing the embankment. Embankment is, you can see, like earthen structure like this. You can see in this figure. In fact, not only in that frequent flood area, but also in saving our cities. Actually, generally we have embankment. Like in Allahabad, we have embankment. With Delhi, we have embankment. Many cities where river flowing is there, then we have embankment. And whenever, due to some maintenance problem or some other reason, this breach is there in the embankment. Look at this. This is the embankment, and there's a breach. So all river water will go to the surrounding area, so it becomes flooded. Now, another one is the drainage congestion. Why it is happening? Because of the sudden heavy rainfall, and our city system, sewer line system is not sufficient to carry out the heavy rainfall water. Then drainage become congested, and water will inundate in the city. So this is one example. This is the Delhi city, and you can see here that people. You can see this. This is the bus. DTC bus, and people are walking. This is the flooded area, but this is a very short period flood, while this is the long period floods. Like in Delhi, you can see that whenever there is a flood, you can see for an hour you will find inundation. After that, it will be all right. Then another region of flood is a storm surge. Whenever there is a storm surge, water enter into the coastal area and it flood. Another region is the dam break. Because of that, whenever there is a heavy rainfall and dam is full, sometimes it happens that the strength of the dam is not sufficient and the dam break is there. That is another one. And finally, there is another region is the glacial lake outburst flood. This is happening nowadays because of that, there is a heavy, that glacier retreat is there. So glacial lakes are formed. And once it is full, then that water pressure is such that it will burst that moraine dam, and finally you will have a glacial lake outburst flood. Commonly it is known as GLOW. So these are the causes of floods. Okay, fine. So let us move further. What is the impact of the flood? This is very important. Flood impact is basically like infrastructure. So basically houses, your house may collapse or house may damage. Roads, it will damage the roads, railway network, communication lines, electricity lines. So it damages all these infrastructure. And these all are the lifeline for the day-to-day activities. Human, there may be deaths, there may be diseases also. And one of the most important, whenever you have a prolonged what you call floods, then there is a psychological problems among the people. An economy, yes, there will be crop damage. Day-to-day economic activities will be stopped. So you will have a lot of loss every day. Rescue and rehabilitation, a lot of money is required for that. Once you have to come out from your area, then you have to go back. Then you have to, spend a lot of money in that. So you lose the economy because of the flood. And finally is the environment. For example, whenever you have flood, there will be soil loss. Then you will have conducive. It is very conducive for waterborne diseases. So these are the impact. Basically, if you see all the disaster, flood is the foremost and most important disaster. It is the most frequent disaster among all disasters. So this is one example. This 10 years like 1998 to 2017. And you can see here that the total events in 10 years, this is only 10 years span. The flood event was more than 3,000. While if you compare with others, you can see this next one is a storm, which is around 2,000. Then earthquake, only 563. Then, extreme temperature like heat waves, then landslide. So if you combine all, it becomes equal to the floods. So that is the importance of the flood. And that's the reason why we should know how to mitigate the flood or how to adopt the flood event. So what is the imaging capability? Basically, if you look that we have to monitor the flood, we have to assess the flood, we have to assess the damage, and we have to do, that risk donation. For all these things, a lot of satellite data is required. For example, geostationary satellite data, which basically 36,000 kilometers away, it gives the information of every half an hour, let us say, every 15 minutes or every half an hour. What do you get? You get the information of the big phenomena, but dynamic phenomena. So what is the big phenomena? Cloud, rain, these are big phenomena. Cloud is not like, a few meter by few meter. Clouds are like kilometers in kilometers only. So it's a big phenomena, but dynamic, it is changing. Cloud movement is there every hour. So not only cloud, temperature, humidity, everything is changing. So such type of phenomena can be monitored using the meteorological satellites. So for India, you know that Kalpana 1, INSAT 3D, INSAT 3DR are used for this weather information. But these satellites are also good for communication because one satellite covers 1/3 of the Earth. So 3 satellites cover entire Earth. So this is excellent information you get at, you can communicate the whatever information you have. For example, there is a match in Australia, you can watch it through this type of satellite. Okay, and of course other communication, disaster related communication also you can do using these satellites. Okay, so geostationary satellites are good for weather information as well as for communication. But there are another series of satellites, and these satellites are basically LEO, low Earth orbit. So what is low Earth orbit? Only 600 kilometers. Compare with this GEO. GEO is 36,000 kilometers, and this is only 600 kilometers. So very close to the Earth. Now, these satellites are excellent for remote sensing imaging. Now, you can image the Earth using these satellites. You can get high resolution data also. For example, CATO 1, CATO 2, CATO 3 satellites are there. Okay, ICONOS is foreign satellite, QuickWord. All these satellites you can, they are all in this orbit only. Not only that, our resource set where LIS-3 and AWIP sensors are there. Again, these satellites are there in this orbit. So whatever remote sensing satellite you are hearing, they are basically from this orbit only. And all optical bands, they give the information during bright sunshine, but all, microwave sensors give the information every time, it's all weathering capability. So you have the satellite in the optical region as well as in thermal region as well as in the microwave region in this orbit. But then other than that, you can always fly using the aeroplane, but nowadays UAV is the most happening technology which people are using for at any time you can fly and you can map the flood and damage, etc. So you see we have the capability in each orbit, at geo orbit, at LEO orbit, and of course very close to us using the aeroplane and the drone or UAV. Okay, so what basically remote sensing offer as far as flood is concerned? It offers near real-time flood inundation mapping. Okay, suppose you wanted to know what is the flood inundation in my district nowadays. So what you have to do? Immediately you will not get, real time you will not get, but maybe in next 4 hours some satellite passes there. You can capture the data and you can analyze and you can give it to the district collector. This is the inundation area. So near real time, this word is very important. It is not the real time, but near real time. Certainly within a day, you will get the information. Of course, flood damage assessment you can do. Otherwise, it is going to be very difficult. For example, if you want to know in a particular city, what is the damage because of the flood, satellite data will give you that all the information, and very quickly you can identify. Otherwise, you have to go to the field, you have to check all these things. Flood hazard zone mapping and vulnerability analysis you can do using the remote sensing data. I'll come to that little later. And finally, lot of inputs you get for flood modeling and forecasting. So these are the major 4 items which you get from the remote sensing. Let me repeat again: near real-time flood inundation mapping, damage assessment, hazard zone mapping, and flood modeling and early warning flood forecasting. Okay, so let us see what is the principle of flood inundation mapping. So basically you see there are 2 sensors, as I told you, generally we use for flood mapping. One is in optical, another one is in the microwave. So in optical, so if you see and compare with the other spectra, you may be aware about this spectra of different object on the earth. One object is like that vegetation. So vegetation curve, it goes like this. It goes like this, right? Okay. But if you see the water curve, highest in blue, lowest in the NIR. So basically, if you see the spectra, it's a very low reflectance is there from the water. It means water will appear black in any imagery. But the flood water is not the pure water. It is having a lot of sedimentation. Okay. So it will not appear pure black. It will appear like this. In the second image, if you see, so it appears, what is this signature? This signature is like water signature, but with the soil. So cyan color. So you can see this is the signature you will get from the optical sensor for flood. Okay. So FCC, it appears black if deep, like reservoir, you can see here. But cyan color or bluish color if shallow, in case of inundated water or flooded water. Clear? So this is how you will see flood water in the optical region. Okay. But now let us go to the another region, that is a microwave region. So what is the principle? Actually any water body, whether it's a flood water or any other water, microwave, generally we are having a side looking radar. So it sends a signal, and water, for them, water is like a mirror. So it reflects back in other direction. So this is theta I to theta R. So if this is theta I and theta R, both are, so this is incidence angle and this is a reflective angle. So it is almost equal. So theta I is equal to theta R. So you can see that whatever it is reflecting more, but in other directions. So satellite will not capture. Hence, all water body, whether it is a deep water body or shallow water body, will appear black. Now you have to separate out that river water body and permanent water body from the flood water body. For example, you can look at this. This is near to Kendrapada district in Odisha, and this is the Mahanadi river. And you can see here, this is the Mahanadi river, and you can see here that this is the river portion. So you can separate out, but all this is the flood water. Okay, so you can capture that. Now, why it is required? Why you can say that optical data is available? Why should I procure micro data? The reason is, that flood. Why flood comes? Flood comes because of the heavy rain. From where heavy rain comes? It comes from the cloud. So there is a possibility whenever there is a flood, there will be a cloud. So optical data will not work. It will not penetrate. So we should have a micro data. That is the reason why we have a RESAT-1 satellite, where you can have a micro data and you can capture the data. One example I will show you. Look at this. This is the same date, but one is the optical data, another one is the micro data. Optical data, what you see, all cloud. You cannot see anything else.
But in micro data, you can see a river and you can see a flooded area. While it is not visible, something is visible here because there is no cloud, but you cannot conclude. But with optical data, immediately you can say, okay, this is the area which is flooded. Okay, so that's how you can see. So we have to see whether there is a cloud, then we should go for micro data. If there is no cloud, we can always procure the optical data. So now you understand that for what this flood mapping and monitoring, you can use optical data or micro data, depends on the cloud conditions. Fine. Now let us move further. So present capabilities. So high temporal resolution, large swath. So this is good for communication. Already I have spoken, but let me repeat again. Now you understand the flood also. So please try to correlate between different satellite systems and your flood assessment and monitoring. So now high temporal resolution means weather information, and large swath because weather is a large phenomena. So it's good. So we have a low space, but only the problem is that it has a low spatial resolution, like 1 kilometer, 2 kilometer, but no problem. It is good for cloud. So these satellites, like for weather and communication, this is required. Medium temporal resolution, large swath. Now these are having coarse spatial resolution, like 1 kilometer, 350 meter, 56 meter. They are excellent. In fact, India is having very nice medium temporal resolution as well as the good spatial resolution, like ABIP sensor. It has 800 kilometer swath as well as the 56 meter only resolution. It's excellent. And this is good for regional scale flood mapping, monitoring and assessment. For example, entire Brahmaputra basin can be covered by one sensor only. Sorry, one scene only. Okay, so any flood which is coming in entire, let us say Assam, you want to monitor, take one scene only ABIPS with 56 meter, you will get this. But we have other sensors like list 3 or 30 meter, list 3 is 23.5 meter. So they are low temporal resolution. Repeativity is only 24 days. Here it is every 15 minutes or half an hour. Here every 5 days. But here 24 days. But it is having good resolution, like 23.5. So medium spatial resolution, local level information you can get from this. But we have many satellites like CARTO 1, CARTO 2, CARTO 3, and in fact ResourceSat satellite which is having that list 4 sensors, which is resolution is 5.8. That is also good. This is good for any damage assessment. Okay, of course, which satellite you will use depends on the stage of the disaster, type of the disaster, and extent and the severity. If you look at the disaster cycle, then how you will use and what parameter you will get from remote sensing. Okay, so let me start from the prior to a disaster. What you need? You need precipitation information you get from remote sensing. Land use land cover map is very important input for flood modeling. Topographic parameter like distal elevation model, slope, flow direction, flow accumulation, all these you will get from remote sensing using DEM. You know that we have CARTO DEM, a DDS network. Okay, so this data support in the hydrological simulation. Now during disaster, flood inundation map, flood monitoring, infrastructure damage, flood evacuation route, relief and rescue, communication. Following a disaster, after disaster, you have to assess socioeconomic loss assessment based on flood damage and crowdsourcing, rehabilitation and reconstruction, and counseling. Long term, these are the things which you go for mitigation. So flood hazard zonation and vulnerability, risk analysis, public education, location of the centers. So this is required for that. And all these, whatever element I put, whatever the points I put, remote sensing provide the direct information. Okay, now let us see one by one separately. But before that, there are, I told you many satellites. So like we have a reset one currently is working. ResourceSat 2A, 2B. So we have a list 4, list 3, labels data. Then of course CARTOSat 1, CARTOSat 2. Nowadays we have CARTOSat 3 also with 30 centimeter or 25 centimeter resolution. So for damage assessment, these are good. And for mapping and monitoring, these sensors are good. There are foreign satellites also, like you can use, for example, precipitation, you can use GPM nowadays. Otherwise, radar set or, NVSat, many satellites, IIRS, LOS sensors. But there are many high resolution satellites are also there, like Iconos. Okay, then we have Orview, Cookward. There are many satellites actually. Thousands of satellites are there. Okay, so I will quickly tell you that how to do it with this graph. Now, this is one example I have taken. This is a little old example, but classical example. What happens? There was a flood, heavy flood in Assam. Generally, every year flood comes. So that satellite data is taking. This is the BIPS data, which covers 810 kilometer by 810 kilometer, single scene. So this is a single scene. Arunachal Pradesh is there. I capture only Assam. Now you can see here the cyan color. Now cyan color, this is the flood water with river. So you have to subtract the river. So you must be having in your database river width. You subtract it, you will get the flood water. Now this is the step one. So what is basically steps? Let me explain you. That it starts with the capture the satellite data, number one. Georeference the satellite data, number two. Third, take out the database from your server, like district boundaries, superimpose district boundary over this geo-rectified satellite image. You will get which district is affected. For example, now, look at this, Barpeta district, it is affected. But what is the advantage? You will get south of Barpeta is affected. You get the location also. What is the inundated area? Nalwadi, it is affected. Dharan, affected. Sonitpur, affected. Nagaon, not affected. Karbi Anglong, not affected. All others. So like that only, you can keep on seeing that. Okay, now let us move to the Marygaon district. Okay, so I will take out only one district. Okay, so this is the Marygaon district and I superimpose the village boundary. Okay, and you can keep on in GIS. That is the advantage of integration your remote sensing data with the GIS. So flood layer, village layer, integrate in GIS, and you will get, immediately you will count, there are 465 villages affected. In your GIS environment, if you have village name, so immediately you will get which village is affected. Not only that, population. So in your, already you have a population, agriculture area. So all this information you will get immediately within few hours only. And that is the importance of the remote sensing and GIS, integration of remote sensing in GIS. And that's how we monitor. Okay. This is a damage assessment. Look at this road before flood and road after flood. Right? You can see road before flood and road damage because of the flood. Now this is one cyclone also create havoc. And if you want to see how the damage of the roofs, let us say. So this is one example, high resolution data. And you can see here roof before cyclone and roof after cyclone, totally damaged. Look at this structure before cyclone and after cyclone, partially damaged. So this type of analysis you can do using the remote sensing high resolution data. So when I say high resolution data means essentially it is less than 5.8 meter. See, there is one very important thing about the flood. That suppose a flood comes for one day and a flood comes for 15 days. The damage of the flood which comes for 15 days is much higher than the flood comes for one day. So the duration of the flood is very important, and that you can find out using the series of the satellite temporal data. Every data you procure, you will find out what is the duration of the flood. Now look at this example I have taken. Look at this. On 4th September, flood is there. You can see this is the river, both the side river. This is the flood. On 13th September, flood is there. But what happens on 19th September? No flood. It means this flood is 19 minus 4, less than 15 days. Okay. Now look at this. 4th September, flood is there. 13th September, flood is there. 19th September, flood is there. You see, this is the flood which is more than 15 days. And you can see, I don't think any crop will survive in this area. This is agriculture, very beautiful agriculture area. No crop will survive. While here, no problem. Crop will damage, but not that much. Okay, here, very little flood is there. Here, no flood. So this is even less than 9 days. So here, no damage. So that's how you can, monitor. And this is very, very much useful for the identifying that how much money to be distributed to the affected people. In fact, insurance people now, many insurance companies, they are basically using this information. Now, this is one example of Kosi flood and how you can see the combination of micro data and optical data. So you know that history of the Kosi flood, it is one of the biggest flood, and the damage also was extensive. Now look at this. This is the before flood, river is flowing, but there was an embankment breach here. And on 20th of August, you can see the flood. Now there was a total cloud. So micro data, now when it is a black and white image, it is a microwave data, and it is a color image, then it is a optical data. So you can imagine yourself. This is at 20th of August. You can see flood water comes up to here. All black is a flood water up to here. Beyond that, there is no flood. So flood wave progressed up to here only. Okay, and this side also extent you can see. Now on 22 August, again micro data because cloud was there. Flood came up to here. Madhepura, you can see town. It is not flooded now, but you can see that it is approaching. Okay. On 23rd, again flood. Now cloud is removed. You can see very little cloud. So we can take the optical data. Flood comes down up to here. Yes, on 24th August, flood come down up to here. Now Madhepura district, now it is in danger. You can see Madhepura town. 27th, now you can see flood came down up to the river Ganga, and you can see Madhepura town is under flood. That's how you can monitoring using the remote sensing data. Now, what is the importance of this? Yes, people can inform you, but you will get exact extent. For example, not only you are getting this extent, you are also getting this extent, left to right, north to south, left to right also. And what you see here, this flood is here, but here in between, there is no flood. So within that also you can find out. So that's how you can monitor and assess the flood inundation using the remote sensing data. You can see 29th August it is there, 3rd September it is there, 5th September it is there, 7th September it is there, and you can keep on, and 10th September it is there. So 20 days already I have shown you it flood was there. You can imagine it. In fact, this flood, that inundation was there till 2 months. That's why I'm telling. This is a very huge flood actually, and a historical flood you can say in Kosi River. Okay, sometimes flash flood comes. This is one example I'm quoting. This is a 2010 flash flood. What I want to tell you, the integration of that weather satellite data, then the flash flood, and then the high resolution data. Look at this. This is the, at 8:30, cloud is there, Leh city is there, Leh town basically. Cloud is surrounded, no problem. 11:30, cloud is intense. And after that, you can see cloud is full cloud at the, over the Leh. So cloud burst happens. Before event and after event, you can see mud flow was there, and lot of, this is the mud flow, and all high resolution data will give you the damage. Okay, so this is how flash flood. Look at this. Individual house is mapped using the high resolution data. So damaged house, partially damaged house. Okay, so all these information you will get. All these information you will get using the remote sensing high resolution data. Okay. Now this is a 2018. This is in Kerala. You can see before and after. You can see this all flooded area. So this is the flooded area. You can capture. This is a micro data we have taken. Now look at this. The 2019 Assam flood, Brahmaputra River. So this is the flooded area, flooded inundation. You can see. This is very actually different techniques, actually different, satellite data, whatever is available. Now, one thing I wanted to tell you, all of you, it is not necessary that always you should take our Indian satellite. During the event of disaster, we activate an international charter for major disaster. Then whatever satellite is there, that day passes there, they provide the information. We get the data from there. So nowadays, it is not like Indian satellite, any satellite. Indian satellite means CSAT-1, Sentinel-1A, Radar Set 2, whatever data is available, you will get it. So every day you can map in the flood area. So that is the advantage. Now cyclone movement you can see using the our INSAT 3D, 3DR satellites. You can see how the cyclone movement is taking place. Okay, now this is another example of Fanny cyclone in 2019. So it created havoc and a lot of inundation took place. So this is, you can see here nearby Puri area, and I zoomed it. Puri is here, and you can see all inundation area. You got it. Okay. Okay. So this is what I have informed you about the flood mapping, monitoring, inundation area, damage assessment. Now let us come to the flood hazard zonation. So flood hazard zonation means what? Flood hazard zonation means I wanted to know that which area is flooded frequently, so that people should not stay in that area. So how to do that? For example, let us see if you are somewhere near to, let us say, Barpeta district in Assam. People know that, people know that that every year flood comes to up to this point. So we should take care. Okay, but how to map from remote sensing? Let us say you take the satellite data for last 20 years. Let us say you start from 2000, and because satellite was there till date, and you find out, but you have to take the flood time data only, and you find out flooded area. Now you superimpose all these 20 images and find out the area where you find every year flood comes. Another area every 2 years flood comes. Another area every 3 years flood comes. Another area where every 5 years flood comes. Another area like every 10 years, every 20 years. Like that, if you capture that area, then you can create a map that, okay, this is the area where every year flood comes. This is the area where once in 2 years, this is the area once in 5 years, this is the area in once in 10 years, once in 20 years. So you will find out, so you can generate a flood hazard map. Okay, so this is one example. This map is generated by NRSC. I captured from the website, and I wanted to show. So look at this. Very low means very high means in a this 10 years. If flood is coming for 10 times, then it's a very high risk zone. Okay, only one time, then okay, in 10 years only one time. So you can say, okay, this is the hazard. So this map is created. In fact, NRSC has created these type of maps, and this is available in the website only. You can also see. But what is important for all of you, because you are undergoing this training program, you should learn it, that basically it is simply a compilation of the satellite images and looking into the frequency of the flooded area. So flooded area concept I have shown you earlier. Now simply apply this. So this is one way of find out the flood hazard zonation. Okay. Another way is the flood frequency analysis. So what is this? This is little mathematics is required in that. So Gumbel distribution we have used. Those who are from civil engineering background or agriculture engineering background, they understand what is Gumbel distribution. Actually, basically, this is used for extreme value approach. So this is basically for flood generally in India we are using. And this says XT is equal to the sigma plus K, the mean of variate plus K means it is a frequency factor into standard deviation. Okay, so this is nothing, simply mean. Okay, so you can calculate like mean, then the mean is X bar. So X bar means basically you take the data. So what we do basically, let us try to understand. We take for example, actually we need minimum 30 years data. So let us start with the 91. So 91 I will find out in a particular river, particular area. I find out out of 365, there will be a one day where maximum river that discharge is there. I will take the data. Now 92 also, maximum discharge data I will take. 93, 94, all. So there will be 30 data, but that is a peak data. Okay. So that will be X1, X2, X3, 4 like that. So I will calculate the X bar mean, okay, mean or variance, mean, and I will calculate the standard deviation, right? Then I have to calculate the K. So K you can calculate by T minus by A divided by Sn, where Yt is equal to minus log of T divided by T minus 1, where T is the return period. So suppose it is a 10 years return period you want to calculate. So 10 divided by 9. So log 10 divided by 9. So minus log of 10 divided by 9. So you will get the Yt. Now what is by N? By N is the reduced mean you can get from the table, and Sn is the reduced standard deviation again from table. So from standard table you will get by N Sn. By T depends on the return period, and X bar and standard deviation depend on their values. You will get the XT. Suppose it is 10 years, so this will be S10. Suppose this is 20 years, this will be X20. So you will get different heights of the flood. So for example, T is 5, return period is 5 year, 10 year, 20 year, 50 year, 100 year. So mean X is so, sigma is so, K is so. So when we flood flow, so for 5-year return period, flood depth will be this much. For 10-year return period, depth will be this much. For 20 years return period, depth will be this much. For 50-year return period, depth will be this much. For 100-period return period, depth will be this much. Now what I will do? I will superimpose this depth in a digital elevation model of that area. So one example I want to show you. Now this is the Allahabad city. So Allahabad city, you know, this is the river Ganga, this is the river Yamuna, and this is the Sangam. And this is the city signature. You can see this is Allahabad city. Right. Now I will play that video. Like when I say 5-year return period, this much area will be inundated. 10-year return period, this much area will be inundated. 25-year return period, this much area will be inundated. 50-year return period, this much area will be inundated. 100-year return period, this much area will be. What you have seen? You have seen that how flood water is increasing. So you can see this much city area will be inundated. Now, what is the utility of this analysis? The utility is, you know that 100-year, you want to save the city for 100-year flood. So you know the depth of the water. So what you can do, you can, construct a embankment of that height, so that water will not enter into the Allahabad city. So your city will be saved for 100 years. So this is the utility of this analysis. What we have taken digital elevation model. We have taken the false color composite, which shows the different, city area and agriculture area, and the value of the peak height, water peak discharge in the river. And then we did the analysis. So we had 3 components: one, DEM from remote sensing, FCC from remote sensing, and values from the field. Then you combine all, you will get this type of scenario. So this is the flood hazard zonation or flood risk zonation for individual cities or whatever you want. Okay. So now I told about the flood inundation mapping, assessment, monitoring, damage assessment, flood risk zonation using the satellite data, as well as mathematical model or statistical analysis, Gumbel approach. Now let us come to the flood simulation. Now the importance of the flood simulation is, now within next 10 minutes I have to speak, so I cannot speak in detail, but try to understand, that's all. Flood simulation, what is the importance? Importance is, flood simulation will tell me, suppose I find out that there is a heavy rain is occurring in upstream of that Ganga basin, or let us say in Uttarkasi area, or let us say in Mahanadi upstream, or any Godavari upstream. I wanted to know what will happen at that particular place. Okay, so how to calculate when flood will come up to that place? So you can simulate. You can simulate like that. Suppose 100 millimeter rainfall is occurring, then flood will come up to at what time and what will be the inundation. 50 millimeter rainfall is occurring, flood will come up to what extent? What will be the extent of the flood in, let us say, Haridwar city? Now Kumbh is going on. Suddenly heavy rainfall occurs in Uttarkasi, that area. I wanted to know, because of this rainfall, whether this will not affect Haridwar city. So I have to do flood simulation. So how to do it? So first of all, we take a satellite data like false color composite and digital elevation model. Then we generate in ArcGIS, we generate some GIS database like these are the important things like stream center line, river bank area, we have to find out. Flow path, what is the flow path of the water? Land use and manning coefficient, that is also very important so that I can find out the velocity. Cross section of the rivers at different places. Okay, and storage area, this I have to find out. So this many things I get directly from remote sensing, many from the field data, and many from the GIS layers which is already available. Okay. These all files is imported here in IIRS. This is one model. This RAS stands for the what you call, basically it is a river analysis. Okay, so this this river analysis system by Hydraulic Engineering Center, IIRS. Okay, so basically in IIRS we import these files, then adjust the cross section, edit geometric data, flow simulation, and calibration validation is taking place. Now this is an example of the calibration validation of this is a cross section, change of the cross section, and then finally I will export this file to that GeoRAS. So you can see generate water surface 10, generate floodplain, and create the flood inundation area. Okay, of course you should have a lot of data from field also, like case data, survey cross section. We have to survey. So whenever there is a for example, our scientists are going to the rivers and they are surveying. Okay, you know that recently Chamoli district that Rishi Ganga flood. Now it changed completely the cross section of the area. River cross section is changed. So our scientists have gone there. They have resurvey that area. Earlier we were having cross section. So again we resurvey and we have put this, and then we have run this model. Okay, how to do that? But before that, so this is the different location. What is the cross sections? This is one example of the Daya River. I am in the lecture. I will call you later. River cross section and discharge data. You can see a different. This is the Daya River basin. You can see a different location. I got the cross sections and discharge data. So this I have to simulate. Okay. Sorry, this mobile is disturbing me. Let me. Okay, fine. So then let us move further. So this is how in a GIS environment you do it. So just example, create a stream center line. So this line is created. Now create a river bank. So river bank is created. Now these options are there actually. So whatever I am telling, this software provides this information. So create river bank. Then create flow path. So flow path, you can see the arrow. Then create cross-section line. So cross-section lines are created. You can see here, if you cannot visible, but it's basically cut lines. Then create storage area. So all storage area and manning coefficient is added, what you call input into this area, this software. Then the DM is required. And finally, it was simulated, and you can see here. Along the river, how it is there. A particular cross section, how it is moving, and over the area, you can see inundation 2D. You can see over the area how it is flowing. It may not be visible, but time is changing, date is changing. So over the area, you can see. So suppose your house is here, you wanted to know when flood will come. You can find out by such type of simulations. Okay, this is the example of Uttarakhand Ganga basin up to Rishikesh. And you can see here along the cross section how flood wave progression is there, and along the river also how this is a I don't know whether you can see in your laptop or in your screen, but very nicely this you can see colors are changing and water is moving. Okay. Now if you see in 3D, this is a Terry Dam, and this simulation. Suppose Terry Dam for that water release is there. So how this water will go into this? Look at this. This is the Haridwar city. So how water will inundate the Haridwar city and other area. So this type of analysis you can do using the flood simulation. This is another example.
Now this is the Kerala flood. I wanted to know I would tell you that how the good is our analysis. You can see the blue color here is a flood wave, and you can see the actual photograph. Look at this. Compare this. This is our study, and this is actual field photograph. This is a bridge. You can see our study, and this is the actual photograph after flood. So this type of analysis we can do, and this is very much useful. Okay, now final, that flood forecasting and flood early warning. So this is the final slide, and how to do it. So basically, for flood early warning system, the most important thing I should know well in advance what is the amount of rainfall is happening in next 3 days, 5 days. So the prediction of the rainfall is one of the most important. So that we get using different models like WRF model, weather research forecast model, or IMD is really doing well, and they are providing the data, next 3 day data to us. Once they provide the data, let us say today the date is 15th. So 16th, 17th, 18th, I will get the rainfall data of that area. Then what I will do? I will run the model, hydrological model, okay, and I will generate the inundation scenario that this much area will be flooded, this much area will come to the river. So I will tell, okay, this area will be flooded or not. So what is important? Prediction of the rainfall. Then all hydrological simulation which I have told you. Then so this can be done real time here, flood waterside hydrology. Total modeling is carried out. Already I have given example of this box. And this is the rainfall. And of course, you need a GIS environment, the different location. And finally, you have to generate such that it becomes a real world kind of situation, which I have shown you in 3D of Haridwar. Okay, so you have to generate the maps like this. Okay, so that way you can generate the flood early warning system. So what you should have? You should have a rainfall prediction method, so like WRM model. You should have GIS database completely, and you should have satellite data, and then do all the analysis which I have told you earlier. You can generate for next 3 days what will be the flood conditions. Okay, this is one example I am showing you, because this we could able to capture 3 days in advance. This is of 2015, Mandi district in Himachal Pradesh. Okay, there was a flood, heavy flood, and 3 days before only, based on our flooding, we told it is going to be heavy flood, and this is the area which we have given. It's a long river, you know that. So we have given, it's the Byas river. Okay, and we told this is the area, and exactly this is a bus stand of Mandi, and you can see the flood condition. Okay, so these predictions, sometimes it helps a lot for any damage. It saves, it evacuates the people. This prediction will tell, and the people, the policy or administrator, that please evacuate the people. So this type of modeling is carried out. So we have the experimental flood early warning of Northwest Himalaya. This is in the experimental stage. Now it is not open to the public, but at IIRS we have this type of system where on website we are generating such type of scenarios. So that's all. This is the last slide. Thank you very much.